present in the PBD3 immunoprecipitation complex, indicating that these two proteins associate with each other. Okay? So that's done here, and then we even done a much more detail reaching during the time course using ionizing radiation. That's another DNA damaging agent. Okay? Ionizing radiation, like people doing radiotherapy for cancer patient. Okay? Ionizing radiation causing the DNA damage as well. Following the time course, as you can see here, PBD3 is elevated because the DNA damage response. And then we do the PBD3 immunoprecipitation and the immunoblood with the TAC 1433, showing that these two proteins interact with each other. Okay? So 1433 sigma does interact with our genome guardian, PBD3. So that's about 1433 sigma. Actually, there's more study about sigma, but I don't have time to tell you all of it. You could really, if you want, if you are interested in knowing detail, you could read some of the paper in the online through the Medline, through the online article search. You will find a lot of research articles in this area. And here I want to move on to some of the molecules we mentioned in the previous lecture about Aurora A kinase, about Aurora B kinase. Okay. These kinases, as we mentioned, they play an important role during mitosis. But once mitosis finishes, they will be degraded, as we mentioned earlier. An important regulator for the Aurora A ubiquitination has been shown that FBW7, that one of the components of an SCF complex, is very critical for Aurora A ubiquitination and degradation. Okay? As you can see here, this was done again through the in vitro ubiquitination process. The reaction was added with a UBA1, ubiquitin activating enzyme. That is E1 enzyme of the ubiquitination process. UBCH5, ubiquitin conjugating enzyme H5A, that is the E2 enzyme. SCF-FBW7, okay? Complex, that's including the FBW7 there, with ubiquitin, with the ATP. Remember, all these have to be there in order for the ubiquitination process to happen. Okay? So you add them all together, you find that Aurora A got ubiquitinated. Without ATP, that's not happening. Without ubiquitin, that's not happening. Without the E3 ligase of SCF, FBW7, nothing happened. Without E2 enzyme, nothing happened. Without E1 enzyme, nothing happened. So this is biochemistry, okay? In a biochemist, do things correctly, accurately, to define the system require what, okay? So it's very, very nice experiment. I like always to say that when you do experiment, like you do in cooking, like, except doing experiment, you need a much better control. Okay? Raise your hand. Everybody know how to cook. Nobody know how to cook? I only see like 5 or 6 people. Good. You should do better. Okay? I say if you don't know how to cook, you should learn how to cook. Because I said, if you want to be a scientist, you also need to be a good cook. If you cannot cook well, I don't think you could be a good scientist. So, if you want to be a scientist, make sure that you start learning to cook. Okay? Cook is much simpler. You add salt, right? You add soy sauce. You may add some spice there. You mix them together. Watch the temperature. Then when this is done, right? Here, doing this experiment, just like doing cooking, okay? You miss one, that kind of dish is sort of spoiled. It's not as successful. So you need to add them all together carefully. Then you have one experiment now. You get a good result. So doing the experiment is just like cooking. Okay? So I encourage you, many of you, to do a good cook, be a good cook. Okay? And then you will become a good scientist. Okay? So it's very important to have this analogy. I think sometimes, especially Western people, when they cook, they like to have a recipe. They usually follow a recipe very carefully. 2 spoons of sugar, 1 spoon of salt, etc. And then they usually use the cup, the thing to measure the amount very carefully. Yeah. But Oriental people, Asian people don't do that way. But that's make our cooking is really a skill, an art. Okay? But I think with that art, you could apply to doing experiments. And you will know one day you could come out with some of these kind of smear gel, and maybe one day will become a Nobel laureate prize winner. Okay. So we talk about that. I think this slide. I think it's worthwhile to overview again. The APC complex is so important, so critical to make sure the chromosome will be able to move to the opposite pole. The cohesion ring is so important to bring the 2 sister chromatids together. The protokinase is involved, and then the spindle checkpoint, we talked about the CDC20. In the end, before the spindle fiber attach, the CDC20 and APC complex is being activated by MET1, MET2, BAP1, BAP3, each protein, to make sure the APC complex is not activated. Once the spindle is attached, this become activated. They're causing the securing ubiquitination. Once the securing is done, separase is active, and then they create all these cohesion rings. So that the chromosome be able to separate into 2 daughter cells. So that's such an important process, and we emphasize why APC need to be controlled that way. Because another way, I want to tell you, the separate, okay, CDK1, okay, we talk about 1-2 things. APC complex is able to ubiquitinate securing, ubiquitinate cyclin B, right? 2 important substrates of APC CDC20. Okay. Cyclin B interacting with CDK1 or the so-called CDC2 is very important to phosphorate on securing. Make sure securing is not degraded. Not important data, I just want to share with you. This is the securing, okay? It has the separation inhibition domain here, okay? Remember securing is inhibiting the separase. Okay, separase the enzyme to create all the cohesion ring. And then securing will do the job to make sure that separase is not activated. So securing, this is a securing protein. With that C-terminal domain there, the separase inhibition domain. When you look at them, the scientists identify there are several important phosphorylation sites in this area. They're using the so-called mass spec, was able to identify the phosphorylation site of these securing. Okay? And it turned out to be a very important phosphorylation site for CDK1 or the so-called CDC2. Okay? And these phosphorylation actually determine the stabilization of securing, because let's take a look here. APC20, okay, APC CDC20. If you incubate them or transfect them and during the time course, take a look at the securing ubiquitination, okay? If you incubate as APC20, APC CDC20, following a time course, the securin got ubiquitinated, meaning that securin is being ubiquitinated by the APC complex, as we expected. But in the process, if you add CDK1 also called CDC2, right? If you add that, then you don't see the securin ubiquitination. But you remember CDK1 or CDC2 need to be combined with cyclin B for that process, right? So meaning that CDK1 is protecting the securin ubiquitination process. This process, if we add another phosphatase called CDC14, okay, CDC14 will be able to dephosphorate the phosphate group on this particular residue. If you add a phosphatase back, then you see the securin ubiquitination happening again. Okay? So the take-home message here to tell you that securin was phosphorated by CDK1, thereby prevent it from ubiquitination by APC CDC20. But if you have that phosphorylation group removed by a phosphatase, the ubiquitination happens again. Okay? This is the securin phosphorylation site that's been sort of mutated. Okay, actually, the phosphorylation site is here. I think they mutate the site. For example, these T and S, the T and S being mutated to AA. Okay, all the phosphorylation should be located in these separate division region. We have these S, S, and T mutated to alanine. It's called the 3A construct. The 5A construct is remove all these potential phosphorylation sites by mutation, by mutated into all the alanine residue. And then you take a look at the ubiquitination event, okay? APC causing the ubiquitination of the securin, okay? But if you mutate it, you will reduce, if you add a CDK1 there, okay, the ubiquitination got suppressed, the red bar here, okay? So based on this and this experiment, you have this bar graph here. But you may mutate those sites away, so you mutate all the phosphorylation sites, okay? Even in the presence of CDK1. CDK have no impact of rescue have no impact in suppressing the ubiquitination. So you will appreciate how the biochemist was able to do all these. Okay? Identify the phosphorylation site, mutate it, and do the biological assay. And then now we find out CDK is the one to protect securin from degradation. Okay? So that means that APC CDC20 activated. You need to kill two targets at the same time. Kill the cyclin B CDK2 activity by ubiquitinating cyclin B. Kill the securin by directly ubiquitination on the securin. Okay? The model is next one here. Okay? APC, okay, if you remember, APC complex is critical to create to make sure the securin is degraded. Once the securin is degraded, the separase will be activated, and then the cell will go to anaphase. Okay? So, but these complex, cyclin B, this was done in yeast genetic system, but in human cell, CLB5 is just like cyclin B, CDK1 is like CDC2, okay, or we sometimes call CDK1. We already, based on the previous experiment, we know these protein complex was able to phosphorate securin, prevent the APC from ubiquitinating securin. Okay. So these are some of the feedback loop regulation here. Okay? Securing, do all the job as we have mentioned. But separates was able to maintain the CDC 14's activity. And the CDC 14 actually antagonized the cyclin BCDK1 activity in terms of protecting security. Okay? So you see right now you appreciate more of the APC's activity. And it's such dedication. Once APC is activated, you need to kill cyclin B, CDK1 activity. You need to cause the security degradation. Very important process. Here, just give you some of the table. I think we mentioned quite a few of these E3 ligase. Their involvement in regulating important protein during cell cycle. Okay? We already talked about APC. Okay? There's a multiple subunit of E3 ligase that will regulate cell cycle. We talk about APC complex impact on security, impact on cyclin B. Okay? Beta TRCP, another E3 ligase, is an FOX protein. Okay? We didn't mention much about its activity, but it's very important E3 ligase component. CUP1, we talk about the CUP1 activity. CUP1 is PBD3 target gene, but also important E3 ligase for P53. And our recent study has shown that actually 1433 sigma was able to facilitate CUP1 cell ubiquitination process. Thereby, 1433 sigma can protect PBD3 through downregulating CUP1. We talk about EMI1. We didn't mention that much about EMI1. This is another FOX protein, inhibit the APC activity. Okay? We mentioned a lot about FBW7. Okay? FBW7 has a role in regulating cyclin E, okay, if you remember. And just now we just mentioned ROLA A, okay? It also has capability to regulate MYC, Notch, CJUN. So this is very important. Only one of the few tumor suppressor gene like E3 ligase. SKP2, we mentioned about SKP2 involvement in regulating P57, P27. Okay? We already talked about the P27 and P57. So they have a role in regulating these cell cycle products. Later on, we're going to talk about something about BRCA1, okay, and maybe a little bit about MDM2. Okay. Some of the things just for your reference, but I think it basically all these literature, these lecture, these three lectures, just to bring you to the door to appreciate the complicated regulation process of cell cycle. And you understand some of these very important cell cycle regulators. They come and go, and there's a reason behind it. Okay? They need to be activated at a certain time point. Once they finish their job, they need to be degraded. So in order to keep our cell cycling process continuing. Cycling get the name because of fluctuation during the cell cycle. Actually, many other proteins, you can name it like that. If you say Aurora is the same situation, P27 is the same situation. But it just, when it was named as cycling at the beginning. But I think you will appreciate this cell cycle advancement was sort of done in the past 20 years also. A lot of knowledge coming along so quickly, and then I hope that I was able to bring you to the door, to the gate, and then you go inside to explore more in this area. Okay? I think we take a break, and come back, we'll talk about the DNA damage response. Okay? All right? Thank you.